The laws of physics would be very hard to describe without coordinates to label the events that take place. As we've seen, there are many sets of coordinates and therefore many descriptions of the same events. What relativity meant to Galileo and Newton as well as Einstein is that the laws governing those events are the same in all inertial reference frame. So, relativity, yes, the same. An inertial frame is one in which a particle with no external force acting on it moves in a straight line with uniform velocity. Yeah. So, inertial frame, straight line, and uniform velocity. It is obvious that not all frames are inertial. Suppose your frame is inertial so that a particle thrown through the room moves with uniform velocity when measured by your sticks and clocks. If I happen to be passing back and forth, the particle will look to me like it accelerates every time I turn around. But if I walk with steady motion along a straight line, I too will see the particle with uniform velocity. What we might say in general is that any two frames that are both inertial must move with uniform relative motion along a straight line. So this it's a feature of Newtonian mechanics that the laws of physics, F equal ma, together with Newton's law of gravitational attraction, are the same in every IRF. Every IRF. Inertial reference frame. I like to describe it this way. Suppose that I am an accomplished juggler. I have learned some rules for successful juggling, such as the following. If I throw a ball vertically upward, it will fall back to the same point where it started. In fact, I learned my rules while standing on the platform of a railway station waiting for the train. When the train stops at the station, I jump on and immediately start to juggle. But as the train pulls out of the station, the old laws don't work. For a time, the balls seem to move in odd ways, falling where I don't expect them. However, once the train gets going with uniform velocity, the laws start working again. If I'm moving in a moving IRF and everything is sealed so that I cannot see outside, I cannot tell that I'm moving. If I try to find out by doing some juggling, I'll find out that my standard laws of juggling work. So yeah, imagine like this. This is the train moving, and you're juggling here. So you are in a moving inertial reference frame and everything is sealed, so you cannot see outside, you cannot tell if you're moving. If you try to find out by doing some juggling, you will find out that all your standard laws of juggling work. I might assume that I'm at rest, but that's not correct. All I can say is that I'm in an inertial reference frame. The principle of relativity states that laws of physics are the same in every inertial reference frame. That principle wasn't invented by Einstein, it exists before him and is usually attributed to Galileo. Newton certainly would have recognized it. So what new ingredient did Einstein add? He added one law of physics, the law that the speed of light is the speed of the light c. In units meter per second, the speed of light c is approximately 3 times 10 to the power of 8 meter per second. In miles per second is about 186,000. And in light years, per year it is exactly 1. But once the units are chosen, Einstein's new law states that the velocity of light is the same for every observer. When you combine these two ideas, that the laws of physics are the same in every IRF, and there is law of physics that light moves at a fixed velocity, you come to the conclusion that light must move with the same velocity in every IRF. That conclusion is truly puzzling. It led some physicists to reject special relativity altogether. But in the next lesson, we will follow Einstein logic and find out the ramification of this new law.